So hello everyone. So our discussion today is about the CTAT simulation, and I'll show you that through the HPI simulation. So as we have discussed in the previous discussion, we can get the CTAT um, characteristic by having a fixed current here, current source, and connected to the diode. And the voltage at the diode will form a CTAT voltage, wherein the voltage across the temperature, as you increase the temperature, the voltage will decrease. And in the standard, most of the books will say that the slope of the derivative of the voltage with respect to temperature is equal to negative 1.6 millivolts per degree Celsius. So that is the slope of the CTAT. So for most of the standard books, but in reality there is a slight deviation. Anyway, so what we are trying to do before simulating the CTAT circuit, first we will discuss how is the diode is manufactured and how it is being implemented in the CMOS process. So as you can see, we have here the symbol of a diode, and diode is basically P and N junction. So P implants in N. So with that, we can connect that into the current source as earlier we have shown, and then we can get the CTAT voltage. So basically the diode in the CMOS, we can structure it to form a PN junction. So so all of the circuit in analog in the CMOS process basically form in the P substrate. So tanan circuitry nasa P substrate. So to form a PN junction, we can implant an N plus here. So with that we have a PN, diba? So we have here ang anode nato is connected to the P and the cathode is connected to the N. So so in this figure, what do you see? What is the problem of this configuration or implementation? So as I'm saying, P substrate is basically mo na siya ang foundation asa nakalay down tanan circuit. So P substrate is always connected to the ground. So the diode that we can make with this configuration is like this. So which is not our goal. Our target configuration, or what we wanted, is to is that the anode of the diode is free to be connected anywhere, not in the ground, but in here the anode must be connected to the current source. But in this configuration here, as you can see, our anode is connected to the ground. So this is not the case that we wanted. So we look for another configuration that would fit in to our diode, which we needed for the CMOS process para ma-implement siya sa CMOS. So another approach of making a diode in CMOS process is balik lang na ako, ang P substrate is always connected to the ground. So we add an N well here. So we have implants of P plus and N. So as you can see, we can connect the P as the anode and the N as the cathode, and we can connect it in that way. So we have the anode, which is free, that to be connected to other circuitry, not in the ground. So pwede kung asa nimo gusto. So free na siya. And then the cathode also. So but in this configuration, nasulbad na nato ang connection sa anode, hindi siya ma-connect sa ground. But there is a problem if you look into it deeper sa katong circuitry. It will form a PNP transistor nga connection that will form a BGT, parasitic BGT specifically. So in that connection, ang PN nga current is the base current. So naa natay dere, and then okay, and so naay mo flow nga current dere gamay sa ato ang base current P to N. But what does this entail? Basically sa BGT, if we have this small current, we will have a large collector to emitter, kini collector to emitter nga current. Okay, P mao ni P pamara pong P substrate. So natay gamay nga current sa PN. So ang entail ana is mas dako ang current to collector to emitter. So mahitabo na akay flow large current from P to the P substrate here. And this is not desired or not advisable because it will create a lot of noise, a lot of substrate current and noise. It will affect other circuitry in which it is common to the substrate as well, because kini, as I mentioned earlier, kining P substrate, this is the foundation for the CMOS, dira ginabutang tanan circuitry. So kung we have another implants here or circuit, it would greatly affect the other circuitry. So it would make the circuitry malfunction, the whole system, because basically affects, it influences kining because we have large currents here. So that is a great problem also. Then the question is, then how will we will make a diode in CMOS process that we can freely connect the anode freely, and also we don't have that a large current flowing to the P plus to the P substrate or the collector to emitter na current nga dako that will influence the other circuitry. So we have here another approach. So with that earlier arrangement, we will add aside from N well, we will add another P well. So as you can see, what is the advantage of this? So nanatay PN same as earlier, but it would happen na kini anod na siya, ang N pod nato connected to the ground, and here connected po ni siya sa ground. This is connected to the ground. So this will configure like this. So our base current kini is also, ang N is also connected to the ground. So P to N, that would flow base current. Pero kung naatay large current na collector to emitter, it will not directly go here, but it will go sa kining P well, and it is also connected to the ground. And the advantage of that is we will kanang pagdugang natog sa P well, wala na substrate current, wala na dire mo abot nga substrate current, and this would entail safer for another circuit sa atong nakakonect sa atong substrate. So this would entail less noise, wala na effects sa other circuitry, so na-isolate na siya. So this is a great configuration or arrangement for a BGT implemented in CMOS nga process. So with that, maka-create na taog CTAT nga diode kung i-layout na nato or i-configure na nato sa CMOS. And we have this general na nga circuitry, the PNP na configuration. So with that, I think I have discussed the importance of having the N-well and P-well na for our configuration sa pag-add na to layer to form a BGT. Now we will go to the simulation in HPICE for our CTAT circuit. Okay, for the CTAT simulation, we will first simulate that into our HPICE. For me, I have saved that into RC, then simulate it, and I will discuss a little bit in here the code. So aside from the library of TT, I also added the library of TT_BIP to call the library for the BGT. And I also declare the global VDD and ground if ever I have sub-circuits. Actually, you can implement it into other circuit coding as well. And with that, RF, I declare it to VDD A1. A1 is the connection from the RF to the to our BGT. So, muna siyang mahitabo. Let's see. Okay, so basically, ang noun dudaanan niya is like this. Oh, dito ka. So, we have VDD and A1. This is our A1. And A1, and I have the BGT, the emitter, collector, and the base. And then the area, PNP10. So, I have a multiple of 1. Then, I have swept the temperature from negative 40 degrees Celsius to 125 degrees Celsius with an increment of 5. Actually, this syntax, you can refer to the command reference HPICE that na PDF that I have given to you sa atong LMS. And I have that OP for the operational analysis for proving the voltage A1 and print the voltage at A1. So basically, to get the derivative or the slope of the voltage A1, I just hold and drag the this voltage here to the expression builder. And it is important before applying what you have put in your expression to put a name unsa ang what would be the name or the result name for this expression. So after that, you have already added the panel and put that in our panel, the derivative or the slope of the voltage A1 or the CTAT voltage. Then you can measure the respective slope by having the cursor that you can get in the measure or so I think that's it. So for the CTAT simulation, so see you in our next video for the PTAT.